Hi, welcome back. This is Professor Ridge, and today's lesson, section 5.3, common factors and factoring by grouping. So first, just want to remind you that factoring is the reverse of multiplication. So if I ask you to multiply, say like 2x times 3x plus 6, well, let's make that plus, not 6, let's make that 9. Oh, that's even worse. Let's make that 19. Alright, so what you do is you distribute. So you get 6x squared plus 38x. So going that way is multiplying, and this is the distributive property. So going this direction would be multiplying, and going the other way we would say is factoring. So what you do is you say, well, what number divides them both? That's a common factor, 2x, and then you factor out the 2x, and which is basically dividing, so 3x plus 19. So that way is factoring. Okay? So, but they're both the distributive property. It's the same idea. Okay, so if we want to factor out the greatest common factor, this is number 10 in the book. Again, what you look for is what's the biggest number divides them both. So 2 divides in both terms, and then they have no letters in common. And so the idea is, we don't ever show the step, but we're dividing. Actually, 4 will go into both. So let's make that a 4. So what you get is you write the common factor, 4, and you divide both terms by 4, so you're left with 2y squared plus 5. So it's simple as that. Alright, let's try number 14. And 14 is 9x squared minus 3x plus 3. So what term divides in all 3 terms? And so 3 goes into all of them. So you write the 3 down. And now you divide out 3 from each term. So 9x squared divided by 3 is 3x squared. 3x divided by 3 is negative x. And then 3 divided by 3. Now this is key. You can't say it cancels, goes away. It doesn't go away. You have to write the plus 1. Because when you check it by multiplying out, if you forgot to write the plus 1, then that term would disappear. So you have to write the plus 1. So make sure you do that. Alright, let's try another one. Number 18. Okay, so let's see. So we figure out what divides in the numbers. 8's the biggest one. So we got 8. And then they all have a t. And you take the lowest. For greatest common factor, you take the lowest power that's common to all of them. So t to the first. Now we're going to divide each term by 8t. So we're going to get 2t to the 7 plus 5t to the 5th. 24 divided by 8 is 3. And then the t's go. So that's your final answer. Again, if you want to check, you can multiply. Now the only thing that the check does is that you factored the number out right, but it doesn't check to see that you got the greatest common factor. So just because these multiply out doesn't necessarily mean you got the problem right completely, because you got to factor it completely. But if you made silly mistakes, it'll catch those. And that's the original one. So again, it doesn't check that I got the greatest common factor. It's just checking that I factored by 8t correctly. Now, if 8t is the greatest common factor, then I did it right, which I did. Right, so write an equivalent expression by factoring out a factor with a negative coefficient. So if we look at 26. Alright, so I'd say as a rule of thumb, if this first term is a negative, you're going to factor out a negative, because we like the first term to be positive. You know, it's not a rule per se, it's just, you know, like a standard way we do things. So, you know, that's why I'm saying a rule of thumb. So if the first term's negative, I generally will take a negative coefficient out. And then now I just ignore the signs. What's common to 5 and 35? So 5 divides them both. Now I'm going to divide negative 5 into both terms, so that would change the signs of both terms. And you get negative 5x divided by negative 5 is just x. Negative 35 divided by negative 5 is plus 7. And there you go. Okay, so again, just as a rule of thumb, if the first term's negative, you want to factor out a negative term, negative common factor. So this, number 30, again, first term's negative. So here the directions are specifically to take out the negative, but I'm just telling you as a general rule of thumb, not a hardcore rule, but if the first term's negative, you generally factor out a negative common factor. So 2 goes into all of them, so I'm going to take out a negative 2. Divide them all by negative 2. You get x squared minus 2x plus 6, because you're dividing each of the terms by negative 2. So it changes all the signs, and then divide them all by 2. Okay, so write an equivalent expression by factoring. So we're just factoring. This new concept here. If I look at 39, and this is what I usually tell my students, so I'm telling you as my student, whenever you see these parentheses, think of that as one number. Okay? So if I ask you to factor something like this, now whether you write the number in back or front, right, they're the same thing. So if I asked you to factor 8a plus 8c, you would say, okay, 8's common to both, and then you're going to divide out the 8 from both terms. And the way, if you could see what I was doing, I would be, if I could cover up the 8's with my fingers, those two 8's become the 1 8 that I'm factoring out, and then you write down what's left over. So a plus c. So if you can kind of just imagine, or you yourself put your fingers over the two 8's, 8a plus 8c, and just cover up the 8's, those two 8's become the 1 8 that you're factoring out, and then the a plus c is what's left over. Okay, so that's the way you do it. Now, in this problem, think of that b minus 5 as that 8. Right? It's not an 8, it's a b minus 5. And no matter what b is, when you subtract 5 from it, you're going to get the same number over and over again. So b minus 5 in the first term is the same as b minus 5 in the second term. So it's kind of like that 8. So I factor the b minus 5 out. Now just imagine me covering that b minus 5 with my fingers, and then you write down what's left over. So what's left over is the a plus c. And that's all you do. That's all there is to it. All right, let's try another one on the next page. All right, so number 42, again, we're going to look at these parentheses as one number. So this, to me, is no different than like x times y plus x times w, because the a plus 5, those are the same. So if I had xy plus xw, I would factor out the x. I'm left with the y plus w. So in the problem I'm given here in 42, the a plus 5s are the same. So again, I'm thinking of it as one number, so I write it down. A plus 5, those two a plus 5s become the 1 a plus 5 that I factor out. And remember, I'm dividing out of there's just two terms here, so I'm dividing the a plus 5 out of each term, and I'm left with the a minus 2 plus the a plus 1. Okay? Now, since inside this second big parenthesis. It's just adding. I can drop the parentheses and combine like terms. I end up with 2a minus 1 just by combining like terms. And that would be my final answer there. Okay, so that's the key step for what we call factor by grouping. Okay, so if you have 4 terms, we do what's called factor by grouping. So our first step is you always look for GCS. So and factor out. Okay, so in this case there aren't any. So step 1, there's nothing to do. Then you're going to split it into 2 groups. That's why it's called grouping. So typically you do 2 plus 2. Sometimes you do 3 plus 1. Sometimes you do 1 plus 3. So you split it into 2 groups. So in this case, I'm going to split it 2. Like 90% of the time it's going to be 2 and 2. There's some special cases for the other arrangements. But anyway, so I got 2 groups of 2. So in the first, just imagine parentheses around those, but I just underline them like that. And then you're going to factor the groups separately. Factor each group. Right, separately. So the first group, what's common to both terms? Well, hopefully you said A, and you'd be right. And then you divide out the A from both terms. You get C plus D. Okay, now you set that aside. Look at the last 2 terms, the second group. So what comes out of both of those terms? And if you say B, you would be correct. Divide out the B, and you're left with C plus D. Now your hope is that the parentheses match. If they do, if it matches exactly, see, that's the key, then you can factor it out, just like we did with 42, 40, or the 39 and 42. So if the parentheses match exactly, then factor out the parenthesis, meaning write it down, right? And then write what's left over in the second set. Okay, so let me show you how that works. So C plus D matches exactly, so I write it down. I'm going to factor it out. Now when I factor it out, I'm going to write the second parenthesis and write what's left over, the A plus the B. And that's it. That's factor by grouping. Okay, let's try another one. So first up, I look for any GCS for all 4 terms. There aren't any. So my next step is I'm going to split them to 2 groups of 2. Again, sometimes they'll be 3 and 1 or 1 and 3, but most of the time be 2 and 2. So I try 2 and 2. The first group I can take a b squared out of, and that leaves me b minus 1. The second group I can take a 2 out of, and that leaves me b minus 1, 2. And that's what I want to happen. If that doesn't happen, I would cross this out and try something different. Like maybe rearrange the groups, switch the order of 2 terms. Again, maybe do a 3 and 1 arrangement or 1 and 3. But the key is these parentheses have to match. If they do, then you're in business. If they don't, then you can't do it. So you write the parentheses down, and then in the second parenthesis you write what's left over when you take the b minus 1 out. And I am done with that one. Your final step for all factoring is, make sure you factor completely. So you look at each parenthesis and make sure that you can't factor anything else out. Okay, so let's look at 50. Same thing, factor by grouping. Okay. So let's see, we're going to get an a squared, a minus 3, We take a 2 out of the first one. Second group, I'm sorry. 3 minus a. Now these parentheses don't match exactly, so you got to note that, okay, if you're switching the order of a subtraction, and it doesn't matter which one we switch, it changes the signs. Okay, so b minus a is not equal to a minus b. They're off by a negative sign. So the way you fix it is you factor out a negative, and now you're going to get the same answer. See, look, if I did 5 minus 8, well, that's equal to negative 3, and if I did 8 minus 5, that's equal to positive 3. So 5 minus 8 is equal to the opposite of 8 minus 5. Okay, so hopefully that satisfies you. So what I need to do then is, instead of doing 3 minus a, I need to switch that order around and factor out a negative, and I'll just put it in front of the 2. And then that switches the order. Instead of 3 minus a, it's negative 3 plus a, which is nice, easier to write as a minus 3, again by this rule over here. Okay, so now the parentheses match exactly, so I can write a minus 3, and then what's left over is a squared minus 2. And I am done. Well, you got to verify that nothing else can be factored, but nothing can. So now I'm done. Alright, so that concludes the lesson for 5.3. Go to my math lab and complete the exercises there, and I'll see you next time.